Start recording. Yay. All right. Today, we got different things planned. I am going to do a little bit of homework pretty soon, but that's going to be for the next section, the 12.6 stuff. And like I said last time, I know it seems like we're a little bit ahead, but now we get the time to work on stuff that y'all want to work on. So we're going to do this last problem. It's pretty easy. And then we're going to talk about the shapes, and then I do like two problems, and we're done. Hi. But we're not done. I want to go to my math lab and talk about this. This is a very cool topic, very important. And then on Monday and Tuesday, at least, I want to just stop, do whatever problems you want to do from the homework. We got plenty of time, and then we can get going on the next chapter later. Cool? Good plan? Is that okay? Cool. That way you can accumulate over the weekend all the questions you want to go over more specifically. So, but we'll do that in a minute. Let's finish up this last problem and keep on cruising. We didn't do this one, right? Like we did the angle one. You're right, right. So yeah, that was just a formula. It's very fast and easy. This one here is brand new. So let me get a new thing here. So find a point P at which the line intersects the plane. Love it. Love it, love it, love it. This is a classic problem here. Like literally like classic for all of Cal 3 stuff. We got a plane, we got a line, and it's colliding with that plane, and we're wanting to find that point P where it's touching. That's all it is. So we got a sheet of paper, and we're good. We got we got a target, and someone shot a bullet through it, right? So we know where the bullet was going. Where did it hit the target? Essentially, that's kind of what's going on there. So pretty cool stuff. How do we even get started? Right? Y'all want me to do it? Let me see. Okay, good. That's fine. Okay. No, it's no problem. I got it, bro. So one thing to keep in mind is that we have a normal vector from this plane, right? So I'm going to make a normal vector, and it's orthogonal. So that's my normal vector. What would be, like you can see there's the line, and this is the plane. So what would be my normal vector from this? Mm-hmm. Mm-hmm. Perfect, perfect. So we have our normal vector. So that's going to be handy, right? Right. Do we have like a slope thing from this? I'm gonna call it slopes for right now. Slopes. What would my slope? Cool, cool. Okay. So I'm kind of getting the feeling here that we got this going on. I wonder if this like initial point also means something. So in a way, we got two vectors. Yeah, two vectors. Do we have something where there's like a kind of like a two vectors that make with a plane or something like a formula that we already have? Surely there's a formula, right? So let's go up. I'm going to look at what formulas we have available to us. Yeah, yeah. So this was a plane and a point. So the distance between S point and a plane through point P. So P is on here. That's S out there, and they're wanting to know the distance D from it, right? That was something like that. So it's kind of similar to this, isn't it? But I'm not looking for the distance. I actually want it to be on there. It's like I'm trying to solve for P in a way. Yeah. So in a way, do we have this vector here? Do we have the normal vector for the plane? I would say yes, we have a normal vector for the plane, right? We already established that. Do we have a vector from a point to another point out there? Maybe. Maybe. What if this is that line equation thing, right? The line vector, if that makes sense. The other vector that we needed, right? We got two vectors. What if I just plop them in there and see what happens? Want to try it? Okay, cool. I don't know if this is going to work. I have other ways of doing it, but this is just, I'm trying to formula. So yeah, we're going to do the normal vector in, and then we're going to do our line slopes, whatever it is, and see what happens. Okay. So let me rewrite that. I got my distance. Again, I'm just doing the formula straight up. PS dot n over magnitude of n. And what if I do put both of those in? What if I put this one as my PS, and then I put this one in my n? I'm supposed to just get a distance? Does that sound right to you? Aren't I supposed to get like a point on the plane? See how that's kind of a little weird? What would then be the distance if I had my point right here on the plane? 0. So maybe I like solve for x or something? You know what I mean? A lot of weird stuff going on there. And I don't want to. Or do we have to develop something on our own? And that's okay too. I've done this problem many times. What I often look at is if we can make a vector, a parametric vector, from, let's just say, t equals 0, and then we can say like t equals 1, and then we can solve for t equals something, wherever it's touching. And then from there, we could just say, that's that point. We plug it back in and we get an answer. That's how Chad does it. Okay, so let's go down the different avenues. Should I plug it into the formula and see if I could just solve for x? Exactly. Very good. I don't have an x. If I plug in numbers and I plug in numbers, I'm just going to get numbers. There's no variables to solve. I'm going to try the parametric version. Okay, so like what I tried to do the formula. It didn't really look right for various reasons. I'm going to try parametric. So how to do this is that I need 2 points. I need a point here and a point there, and I'm going to like basically see where in the middle they can go. Oh, even better. We don't have to create these 2 points. It's already kind of created for us. What if x, you plug it in? Y, you plug it in. Z, you plug it in. How simple. Watch this. When I plug it all in, what happens is that I'm putting those points, that line, into this equation, and it's kind of like I'm solving for t automatically. Now, I got to say, I did look through the stuff a little bit today for this, but I purposely didn't try to solve this one because I wanted it to be fun and imaginative. What if I plug them in? And I need to solve for t. That's what I was saying, right? Solve for t. But now, look at the big equation I have here. What do I need to do to solve for t? Simple algebra. In other words, simple algebra, right? You're exactly right, though. You're exactly right. It's things that we've done before. This is easy stuff, right? Distribute, combine like terms. That's all easy stuff. So let's do that. 28, and I've got a 42, negative 60, 70t, 54. Okay. Now I gotta like actually do like arithmetic. We laugh, but it's true. From there, I would get a 10, and then that would be a negative 50 out of all those. Then these guys, calculator. I give up. I give up. Okay. And it's okay if you get a negative number, by the way, because it just means it was before that initial point. It was just in the other direction. Lines, like I drew a unidirectional, but lines are technically bidirectional, right? So just a little factoid there. Man, my handwriting's so bad. I can blame the tablet. That was a good point. Very good point. Yep. I'm careless with my words, and you caught me in them. So this is not the final answer. Remember that I was trying to solve for t. I want to know where on the line, like I want to zoom out here, so let me do like that. I want to know where on the line it would be colliding with the plane, right? I was wanting to solve for t. It's not 0, it's not 1, it tends to be negative 2.46, whatever that is, right? But I need to have a point. What should I do with the t value? Plug it back in. Exactly. We have formulas for all those. So x is equal to, I'm going to go sideways here, -4 plus 6 times t, and I'm going to get a number. Y is equal to 6 minus 7 times t. Z is equal to -2 minus 6 times t. We have all that stuff. So what I'm going to do, to make it most exact here in the calculator, I'm going to say t equals the fraction. And then I can just type the other stuff. So -4 plus 6t, 6 minus 7t, and -2 minus 6t. So it's kind of like already taken care of for me. Fraction, fraction, fraction. Let's pause for a second here. That looks crazy. But let's go to the answers. What do they got? Oh, what do we got? Is it it? It worked. It worked. Ha! I know. I wasn't expecting that, honestly. I just think this problem is so fun. And that's why every time I totally forget how to do it. And then I'm like on the spotlight and somehow I just pull it out. Like, but what I'm very familiar with this problem because I use it on my video games. What you're doing is detecting if a gun shot, like a ray, I know we use bullets and guns and stuff like that. Anyways, you go through a polygon, right? So the polygon would be a plane. Here's the biggest one. Now that we've discovered when it collides with the polygon plane, is that within the actual polygon triangle A, B, and C? Or did it miss it somewhere? I mean, it's on the plane. The plane goes forever, but is it inside the triangle? Ha 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 ha! Heavy math. But we're not doing that today. That's totally not part of the lesson. But it's cool though that we can use this stuff. I know that video games, but whatever. Yeah, go ahead. Yeah, because it's three-dimensional, so it's Cal 3. Exactly right. Well, the people who make the engines have got to know this. Everyone else just says, make it go. Yes, like the Unreal Engine and all that stuff. Yeah, someone's got to know this math. They use this in linear algebra. Those are the two big things. So Cal 3 linear for sure. Cool. Any questions on plugging it in? Right? Not too bad in the end. It was scary. I looked for a formula, but in the end it was kind of simple, so fun. Okay, last section, and this is the fun section because it's literally all multiple choice, all of it, and you can't get away from that. The exams, when I actually do pull from this, the exam pool normally is like 2 or 3 questions each, so like you might get the same question as you, depending, but like this one, I've got the pool is 30 questions for one question. You'll never get the same question. I know that's kind of weird, but it's fun because it's always new. So y'all had described it as 3D conics, basically, and it kind of is that. If you took away the z's, then you're basically having conics. So if you add the z now, it's good to go. Exactly. Now, what I want to do is show you similarities before we go there, but I've got to rotate the screen because it's just not going to work like that. So y'all rotate as you need. So let's start with the easiest one. Ellipsoid is like an ellipse, obviously. The main characteristics is that they're all positive. And I want to add that in there. You might want to as well. If all 3 are positive, it's an ellipsoid. There you go. And what happens is that these A, B's, and C's are kind of like little radiuses. I'm going to call them radii because that's technically the plural, I think. Radii. That's not a good word. That's a Chad word. But that's kind of what's going on. It's the distance from the center. So this particular one that you see there, it's kind of flat, right? So the Z or the C would be smaller because it was a smaller distance for that. But my X distance and Y distance are bigger. Cool? So we'll look for that kind of thing, okay? Keep cruising. Hyperboloid of one sheet. If you look at the positives and negatives, you have 2 positives and 1 negative. 1 negative, 1 sheet. 1 negative, 1 sheet. This is how we figure these things out. 1 negative, 1 sheet. That's how that works. And How you know where it's revolving around is the thing that I call the odd man out. Odd man out. And so if you look around at all your different variables, you have a positive x, a positive y, and a negative z. So z is the odd man out. The odd man out is telling you what the axis is that it's revolving around. Okay? That's how you would know if it's an x revolve or a z revolve or something like that. Odd man out. Again, that's a Chad word phrase thing, but it works every time.
So just for clarification, based on the way like it's stating it's both, they probably one's negative and which ones are positive.
Yes, they'll try to fool you too. So you mix them around so it looks like this, and you'll have one positive or two positives, one negative. You're good to go. Cool. So far, are y'all okay with? Because we can go back through and we're going to see a ton of examples. But you kind of getting the gist. Okay. Let's go on to the two sheets. So two sheets, again, because you got two negatives. And again, I always like to write that positive in the front. So, same thing, two negatives, two sheets. And that's how I remember that one. Again, we're always looking for the odd man out. Again, odd man out is telling you where it's revolving around. And notice this time it was a z that was positive. Therefore, it's the z that we're revolving around. Odd man out. Odd man out. Okay.
The odd man is the axis.
Yes. Correct. That's the axis that we're moving. Yeah, that we're spinning around. Yes. Very good. That's right. Odd man out. The cone, if you haven't noticed, every single time we've had an equals 1, an equals 1, an equals 1, all of a sudden the cone equals 0. Okay? So the cone is an equals 0. That's the big change between that and this one. Now, notice that this is a positive, positive, negative. So what it's going to resemble, again, odd man out, right? Odd man out. This one would resemble that one sheet, but it just got squished in the middle, right? So it looks like a one sheet. It's just that it has a 0, so now it's got squished. It's like you put a belt on it really tight, right? And it just... Yeah, exactly. Exactly right. But it looks the same as the one sheet. It's just that it got sucked in right there. But everything else applies is all the same. I don't know if there, and I mean, maybe I just forgot about it. If there's like a 2 sheet equals 0, I can't really remember that. If it's not here, I'm not worried. Okay. Oh yeah, 3D Desmos. Oh yeah, you can use that all the way across all this.
Well, I was saying to see if it would have the same thing or not.
I'm scared. I don't want to. But I mean, I have never encountered it. But I mean, if there were 2 minuses and 1 plus and a 0, then I would consider just a second. Oh, it might end up being one of these kind of guys. We'll see. Anyway, so the big difference here with these guys is that we have a z equals. But notice there's a bigger difference. Not just the fact that it's z equals. If you go back every time you have a z, it's always squared, isn't it? It's always like the other guys. But here, it's completely different. Whole new breed, okay? And so that classifies the paraboloid, I guess, zone. And it's very simple to do. Like, if you ever wonder, what does this look like? You can always, with any one of these, you can basically just get rid of one of the dimensions, and what do you got now is a parabola, right? So then if you add it back, you get a paraboloid. Same thing with all the other guys, in case you were wondering. Same thing here. I get rid of one. What are we looking at? Parabola. Now it's paraboloid. So the difference between them is obviously obvious. There's a big difference, right? But we're seeing again that this is a positive and that's a positive. Everything's positive, so it's going to go positive, and we're happy and we're normal. Everything's fine. It's like a regular old parabola. Yeah. If you got rid of your x or your y, it wouldn't matter. It would look the same. Okay? Because it's both positive. Everything's fine. We don't worry about that. But because there's a minus here, this is technically a positive. I wish they always had a plus in the front so you could see that.
because they're opposite signs, you're getting two different parabolas. So this is the hardest one to draw, but I mean, you could see it, but we got a parabola that's going up, okay? But at the same time, like literally the same function, we got a parabola going down. So it's like you got a negative and a positive kind of together. And again, it's easy to see in 3D, and we get it. We call this the saddle. Is the saddle. So we understand it. It's not a big deal. But trying for you as a human to draw it is just nuts, man. So I have a very difficult time trying to draw that stuff. But as long as you're kind of getting the gist of it, right? Saddle. If you think saddle, yeah, goes on a horse. Cool. With these, we should be good to go. I mean, the only things that are missing are like the planes, lines, and other things that we've already seen, right? Those are the very simple ones. These are like conics in a way. So let's do these two. I'm gonna like unrotate, I guess. So let's do these two, and I'm gonna jump to MyMathLab and do more. There. So it says match it up. So right here, looking at all these, hold on. Oh, let me draw it. You're gonna let me draw it? Which one would you say? Yeah, it's a positive, positive, positive. Everything's positive. So probably like an ellipsoid. There any other ellipses up there? C is actually supposed to be a one sheet. If you're looking at it, it's kind of like it's bowing out from that one. Yeah. Like that's a wind tunnel. Versus like a soccer ball that got deflated. So an ellipsoid. Now I know that they have elliptical parabola and elliptical cone, but the bigger difference here is that those are parabolas and cones. The elliptical is just describing it going up rather than two different directions or something weird. Cool with that? Positive, 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 everything's positive. Now, do I have to actually like solve for it and like, get a common denominator and blah, blah? No. You just look at it, you get it, you're done. Okay? Don't worry about it. This guy, what would you say? Yeah. There you go. There's a 0x squared. So what would this look like in 2D? Look, let's do y and z. What would that look like in 2D? It'd be ellipse, yeah. And I don't know if it's y bigger or z bigger, but it's an ellipse. Yep, so we got an ellipse, or circle-ish kind of thing, right? But now, I don't have any x's. And it's not that x equals 0, it's that x can be anything. Plug in x equals 0, what happens? Plug in x equals 5. Plug in x equals 100. I like that. See, that there's an ellipse. It's a 2D ellipse. And it goes on forever, essentially. Correct. Yeah, x. Yep. See how we got y and z here in our 2D version? So y and z and x is coming in and out of the page. Could be anything. Technically just a two-dimensional version, right? That's the 2D version, not the 3D version. It just so happens to make it look like a 3D. I just have to, basically. So what do we call that one? It's a cylinder, isn't it? Just simply a cylinder. I guess that, don't they? In regular conics? Oh, it's not a cylinder, it's a circle. Oh, gotcha. Okay. But then you're taking a circle and making it 3D makes a cylinder. Like a can, right? Okay. And what you can tell is that just by these two, there's going to be special conditions once in a while. And that's why I say MyMathLab. All right. Because I want to go to MyMathLab right quick and do about 50 of them. So, I mean, that's just what we're doing today. And we're done with, that's like that. It's the end of the chapter. So I already got it pulled up. In case you haven't noticed, the homework is like at the bottom. So This is all fun and games and stuff. And I mean, if you like interacting, they're there. Go ahead. Oh yes, I have that. I'm gonna I'm gonna send it out right after class, and I'm gonna put it in Blackboard so that you just grab it. No. Yeah, I'm gonna give it to you. I got it. I got the code. I'm gonna post it in Blackboard.
I actually meant to ask that earlier, but I forgot.
I got it. I got to go find it. Yeah. Thank you. Okay, so here's your actual homework down here, right? And where did it go?
I don't. Your pop-ups, you have to allow them.
No.
Otherwise,
Okay. Thanks.
yeah, otherwise it just keeps sending back to this. Yeah.
I see. Thank you. 12.6. All right, cool. So these homeworks I created myself. So if there's some problem, you tell me and say, "Hey, Chad." Yeah, I know. That's good though. You say, "Hey, Chad," and I can get rid of it. I can just, I don't know. I could do a lot of things. These are personally created. I don't want that. Okay. So we already saw this one. I'm just gonna keep moving. We actually saw this one. I think I probably just took number 1 and 2 and just said, "Well, go do the rest on my math lab." So here's something new. Like that's the entire problem right there.
Yeah, because it doesn't interact with y, so therefore it can be any number.
Right. So in a way here, y would be the odd man out in a way, if you want to think of it kind of like that. I don't have a y, so that's where I'm spinning around, and it would be a cylinder or a circle. Yeah. Very good. Very good. Oh, okay. Cylinder. Right. Sweet. Okay. Uh-oh, there's a minus sign. Now, this is 3D. There's an X right there, isn't it? But is that in a nice, easy format? Mm-hmm. Mm-hmm. So, yeah, exactly. That's what we're, yep. So we got a 16x minus, it would be plus a y squared, minus a z squared is equal to 0, technically. So because it's equal to 0, I'm thinking cone. Like, but this guy right here doesn't have a square. So I'm thinking not a cone, but a parabola, right? Or parabolic blah, 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 blah. You know what I mean? Out of the 6, this one, the parabola is kind of the dominating version. So far, making sense with that? If that's the case, I'd actually like to go back to the workbook, and I'm going to rotate it one time so I can reference these guys. If that's the case, notice that it already has a variable equals blah. A variable equals blah. It's already set up. I shouldn't move it around. I should look just the way it is right now. Which one?
It would be a.
Because it's called a saddle. You got a positive and a negative. Okay, where's my saddle? Yeah. Now you got the fancy name for it. You're going to go, let's go riding our horses. Oh, just hold on. I need to grab my hyperbolic paraboloid. Okay.
Or it's that chip, the chips that come in a can. Oh, Pringles.
Oh, the Pringles. That's a good, yeah, I didn't want to promote a company, but that sounds legit. So, interesting, right? If we have, okay, I want y'all to do some of these on your own.
This one's C.
For sure?
I'm pretty sure because actually the odd man out.
Oh, dang, you're right. And it would be. If I move these all over, I'd have x squared minus y squared minus 4z squared equals 0. Cone. That's my first. And notice, all of them are squared, so it is indeed a cone. Which one's the cone, right? And if we had to differentiate between the two cones, he's the one that is positive. So he's the odd man out. He's my rotation axis stuff. Yep. Cone. Awesome. Cool. It even says it's a cylinder. So then who would be the odd man out? He's literally gone. Z. Z is the odd man out. He's gone. Yep. Oh, that was way too fast. Okay.
So this one doesn't interact with X, so therefore it should be C. There's a lot of C answers in this one. I'm realizing.
Yeah, I like it. I like it. And that's indeed true. If you see there's no X's, so he's the odd man out for sure, like way out. And that would be my, I want to say like rotation axis stuff, but it's more like just the thing that's extending, I guess. The stuff you're not ever interacting with. It's not changing. Yeah, exactly. Yep. This one is a disc. You're like, yeah, they're all discs. So look for the one that would be flat, right? And you're thinking, well, he's going to be big. If you look at it, and I divide by the 9 everywhere, let me divide by 9 on all of these. So I got a 1 now over there. These guys cancel. So like what do I actually have there is a 1 versus a 9 and a 9. So which one? Who's what?
C.
C. X is flat. Flat X. Small x. Yep. Good? Yeah, good? Just making... Okay. I don't know. If you want me to talk more about it. So here's some interesting, you don't have to do any math. Look, this one's a perfect ball, right? It has all the same dimensions. Do we have all the same dimensions? Not at all. This one is a football, so that looks more like that. This guy is squished in the middle, as in equals 0. We don't got an equals 0. Now, if you're ever stuck, and this is all totally fine, if you go to Desmos, they have the 3D grapher stuff now. Although we can't use it on an exam, you will only have one of these on the exam at max. But it's good to just back up and just like, one thing in particular, the strength of this is that you can like move it around and rotate it. So see, I can zoom out, I can move it around and look. I mean, that is like super awesome. And I would say please try to do that. On the final, you can use this. So, I mean, why not, right? Actually, I don't know if you can. I'm gonna have to ask. I'm gonna have to ask about that. The boss can verify. Well, like traditionally, we always say on the final you can use anything on Desmos. I'm fine with it. I don't think it's going to help you as much as you think on the other problems, but this one it would help you, I guess. Well, I'm going to verify with the boss. As of now, I'm going to just leave y'all in limbo there. Which one? What do you think? Z's odd man out for sure. Yeah. No. Oh, here's another Z odd man out. Look. So we just excluded this guy, which was nice, but it's this one. So then we have to say he's got a bigger X and a little Y. You're thinking, oh, well, he's got a little X and a big Y. Again, that's inverted thought, right? Because we're looking at division. It's the division of all that stuff. Let me refresh this here. So if I wanted to get a denominator for both of these, and this is where it gets a little funky, that would be a 1, and this would be 1 over 64. And so this is 1.0, and this is like 0.00125 or something weird, you know what I mean? So this is tiny, and this is big in comparison at least. So I would have a big X and a tiny Y. Right. It's significantly different. I'm gonna leave it wrong though, just to irk you. I personally don't like when they have drawings like this, but we have to be used to it nonetheless. Yeah. It's not ideal, but You will encounter this in the real world because our renderings can't always be perfectly solid. We have to see through it too. Which one? Mm-hmm. Yeah. Because it's X, so it's going to be one of these guys where it's with the X. Mm-hmm. If you say it. Cool. Good. Yeah. Because Y is going to be smaller. Yep. Bigger numbers in the top, smaller numbers in the bottom, essentially. We're looking for those bottom numbers. If I move everything over, set it equal to what? 0. So it's definitely a cone. Yes. Yes. I like D. I like D. The odd man out's Z. Yep. If you move all these over, they'll be negative, and it's equal to 0. 0 means cone. So we got a cone going on. It's one of these three, right? So then which axis are we revolving around? Well, the one that's different is Z. Yep. Now this one is a little... No, it's fine. Because, yeah, you can move it over.
Also, X and Y are larger than Z if you move it over. So therefore, they're going to grow more rapidly than Z, which you can see as the code goes up and down, larger on... It gets larger on X and Y before it gets any higher on Z as well.
I mean, I definitely agree with you. That's very good. I personally think, and we're going to verify here, that MyMathLab is scaling it for our benefit because otherwise, you see what I'm saying? That's what we got, and that looks phenomenal. Look, we got a cone, and you're like, what? So I think that's a scaling thing, and you're right though, because of that 49 there. What if I had changed it to a 1? Now it's a cone. So maybe sometimes if you can't get it to work really well in the grapher, get rid of a number and see what happens. Might be better, because that's definitely cone right there. Exactly. You're scaling it so our human eyes can see it better. Yep. Very good. Yep. Sure. How many minus signs?
There's one minus sign.
So you like B? Yeah. Z is the odd man out. 1 minus sign, 1 sheet. So like this guy's excluded. He's definitely not this guy. So it's one of these three. And yeah, Z is the odd man out. So he's the axis dude right there. Boom. Yep. And I mean, you can see we're not. I want to look ahead here. We've got 26 total. We're on 13. We're doing pretty well. So, let's keep cruising. I mean, I love to see the new ones. It's not boring to me. 2 sheets. 2 minuses, 2 sheets. So it's definitely going to be A, B, or C. Who's the odd man out? Mm-hmm. Yep. See how it's revolving around that Z axis right there? Yep. You got it. Very good. Very good. Did I already do those or something? Okay, there we go. Cool.
I feel like this one's going to be a saddle.
Yep. Z doesn't have a square, so it goes back to those two where it's just the Z equals, or whatever it is at the time. So it's one of those. And yeah, we got a positive and a negative. So saddle. Oh, great. You got 3 saddles. Good job. No. So Z is the odd man out, and so Z should be where you're sitting, like that's the saddle. So this one and this one are both legit, but this one doesn't make any sense. See how it's like a horse, I'm sitting down on it. So this one is cool, and this one's cool. Yes. And that's why, that's why it's better to sometimes just to draw it, to graph it here. And again, I might get rid of I'm going to get rid of that 81 because it's just too much. Oh, the home button. Oh, yeah, okay. Easy. So yeah, we're looking at who got positive and who got negative. Where is it going up? Where is it going down? So on the Y's, it's going up. But on the X's, it's going down. See how like it went down for the X? So we're looking for up on the Y's, down on the X's. Yeah, A. Mm-hmm. And again, you can see that here. My Y's are positive, so they're going up, and X's are negative, so they're going down. Out of all the shapes, though, the saddle is the hardest. The saddle is the hardest, even for me. I don't even know how this. Look at this crazy shape. I don't even know what's going on. And if you look at it like this, you can see it looks like two diagonals. Like it's just there's so much that you can talk about it, but I just don't.
So I do have one question.
Oh yeah,
Question.
yeah.
So if y was negative and x was positive, would it have been c?
Yes,
Okay.
yes. It would have been up on the X and down on the Y.
Okay.
Mm-hmm.
Looks like the saddle can do a variety of different
Oh yeah.
mathematics depending on what you're looking at, at least in 2D.
Yeah. No. Yeah. Yes. Exactly. I mean, because it's conics, you're taking a bigger shape and you're cutting it with these lines and planes and stuff. Yes, there's all kind of different things with the saddle because it's wild, man. It's wild. Yeah. Exactly. You look right here and you see a parabola. You see here and it's a parabola. You look up here and it's the two lines. You know what I mean? So it's like, yes. See? Yes. Yeah, it's tough. It's tough. And same thing here. Actually, a little different. So we have a 1. You see that? But then we have a positive and a negative. If we didn't have the 1, I would say saddle immediately. But we got a 1. What would that 1 do to it? Before I type it in. Is it going to make it like one of these other shapes? Or is it going to do something else? Shift it up. That's exactly right. All I'm doing is saying whatever I had plus 1. So it's still going to be a saddle. I just went up 1. And you can see that. See, it's above. It went up 1 right there. Went up 1. So it's still a saddle. Still a saddle. Just went up 1. Cool. The sphere?
It would be B because both are positive.
Okay.
I forgot what the
I like that.
elliptic paraboloid, whatever it
Yeah,
is.
paraboloid. That's funny. So the difference between a cone and a parabola is, well, first off, they're both squares. I can't remember how this comes about. We know how to get a two cones, right? The cone on the bottom and the top. How do I only get it on the top only? I don't know. that's not here. So I let that one go. Yeah, it's a parabola. And again, you can like erase one of these variables and you can see it's like z equals x squared. Yeah, exactly. We don't have a z, so in 2D land it looks like a what?
It's a cylinder.
Cylinder, circle thing, yep. So it's a cylinder circle thing. So the odd man out though is Z, right? He's gone. So yeah, Z is going to be that rotational axis stuff. That one's cool, but again, it's changing. This is always the same for all my Z's. Yep. It's a circle or it's an ellipse and just go up and down. Yep. How many sheets? One sheet. Yep, one sheet. So, well, there's the only one with one sheet. There you go. Yep. Oh, we got more. We got more. I love it. I'm gonna do it all. I don't care.
It doesn't interact with y, therefore it's B.
Yep. Yep. Y would be that very odd man out. Yep. Very good. What shape? If I move it all over, then it's equal to what? Yep. So, yeah, it's equal to 0, right? When I move them all over, equal to 0. Doesn't that mean cone?
Right.
I'm thinking also, again, let me go back to a blank page here. I would love to say that it was a 2-sheet parabola, blah blah, whatever it is. The 2 sheets, right? When I move these over, they're going to be negative. That's positive, but we're leaving a 0, and that means that it's more cone-like than anything. I don't know. It's just a cone. You got a 0, it's a cone. So, yeah, if you have an equals 0, if you had an equals 1, then it would be the 2 sheets because those 2 guys right there. Yep. Cool. This guy. Oh, just A.
Right.
I thought you were like gonna finish the sentence. That would be A. So again, it is a parabola, but notice that they're the same, right? So it should be the same. This guy's different. He's got like more X than Y, basically. Oh my, that's fun. And notice, like sometimes, like okay, engineers, mathematicians, that's who we're talking to right here. You're going to be using software at some point to visualize stuff, and it's not always the best. I'm just going to tell you that it's not always the best. You have to kind of work with what you got. So which one? Yes. Correct.
I want to say it's A because X and Y do not. Right, because they don't have the denominator of those is 1, so it's not going to go as C upwards as C is.
No. So why is that? It's because again, you erase one of these guys, you're just getting a regular parabola, and then I just make it a paraboloid. And there's really no negatives going on here. X and Y, make any X and Y values, right? Plug in 5 and 2 or negative 10 and 1. So this negative part down here doesn't make sense. See how that works? Oh yeah. So notice over here on the side we got scaling, right? Scaling is a little different scale. It's hard for me to rely on scaling as a good way to know the shape. I know you were saying, well, this should go up faster than that one. 3D land, it's tough. It's tough. I mean, I get you, but it's tough. Okay. Okay. 2 sheets equals 1. Love it. That's great. Yeah. This one you move the 1 over and you move all these guys over. So you'd have 2 negatives equals 1. So if it equals 1, it's definitely 1 or 2 sheets. We have 2 negatives, so therefore 2 sheets. Yep. Very good. Oh, is there another thing down here? Continue? Have I not been continuing? 2 sheets. They don't have 2 sheets. Hyperboloid, regardless. They didn't put the 2 sheets here, but it's hyperboloid, I guess. No, I didn't make them. I put it together. I didn't make them, but I put it together from a pool, and so yeah, you can always blame me for the homework. Good. That's right. When you move this guy over, he becomes a positive. So you got all 3 positives. What would it be then? Mm-hmm. Yep, A or C are both good options, but this one has all the same numbers. Right. And we don't have the same numbers in the bottom at all. Yep. Very good. I think this is the last one. Oh, continue. Have I been skipping those? Ellipsoid. There we go. I know, right? Okay. I think that's the last one. There's no other ones. Yeah, there's an equal 0, and they're all squared, so cone If I had a different cone, I'd look for it, but that's the only cone I got. So continue. Cone, cone, cone. There you go. Just, yeah, it's a cone. Cool. We did all of the homework in that section, except for these 2 problems, which we did beforehand. Cool, right? I told you it's all multiple choice, right? It's fun. It's a fun section. You know what? I'm going to leave it. So we got 10 minutes left, but I don't want to start the next section. The main thing is that I want to go back through homework problems with you guys. So again, starting from the very beginning, anything in chapter 12, find stuff you don't like, things that you say, hey, Chad, maybe you should class. Cool? And that'll do Monday and Tuesday, maybe Wednesday if we're kind of, feeling it. And if we're really, really bored and real, don't bring nothing, then I guess I have to do the lab with y'all. But that I'm not worried about labs. We'll do them eventually. Good? Okay, good plan. Thank you, guys. I guess I'll see y'all around.